This video is on solving linear inequalities by graphing. We're going to be doing word problems. Kelly can work for her dad and make $6 per hour, or she can work for Jana's mowing service and make $14 per hour. She needs to make at least $84 and can only work 10 hours total. She can work at most 5 hours for Jana's mowing service. Write and graph a system of equations that represents all of the possible solutions. So let's think about the information we're given. We know that she can work for her dad and she can work for Jana's mowing service. So let's focus on those two variables. X is number of hours with dad, and let's go with Y is number of hours with Jana's mowing service. So I'm going to call it JMS. So if I write it out over here, I'll put hours with dad. And then on the Y, we'll have hours with Jana's mowing. So let's write a system of inequalities. All right. She makes $6 per hour with her dad and $14 per hour with Jana's lawn mowing. And she has to make $84. But we know that she can only work 10 hours total. She can also only work at most 5 hours for JMS. So there's multiple things here. Well, let's start with the $6 per hour with her dad. So we can have 6x plus, she'll make 14 per hour for JMS, 14 for Y, but she needs to make at least $84. So at least means greater than or equal to $84. But we know that she can only work 10 hours total. So that would be for both sets, that'd be X plus Y can work only 10 hours total. So she can work less than 10 hours, but she cannot work more than. So less than, but she can work 10 hours. But there's still another piece. She can only work at most 5 hours for Jana's mowing service. That's Y. So Y has to be at most 5 hours. So Y has got to be less than or equal to 5. We actually have 3 inequalities here, so we have to be super careful when we're graphing these. So the Y's, we know we have to go up to 5, but on here, the Y would have to go up to 10. Because if I were to cover things up, I'll cover up the X, and the Y would have to go to 10. The X would have to go to 10. So that's our minimum we can have. So if I were to do the same thing for the other inequality, 84 divided by 14 would go to 6. So my Y's would have to go up to 6. So far my Y's have to go up to a total of 10. Then what about the X's? X's, 84 divided by 6 gives us 14. So the X's have to go to a total of 14. So what could we count by? For the X's, I have to go up to 14. So I could count by 2's on my X's, or I could just count by 1's and just go off of the graph a little bit. I think I'm going to do that. I'm going to count up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'll do 12, 13, 14. Going off the graph a little bit is fine. But then the Y's only had to go up to at most 10, because when I divided by 14, I got 6. So I can count up, so 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 3 inequalities we have to graph. I'll graph the first one in pink. This is where I really need to know where my X and Y intercept are going to go. So for my X, I completely cover up the Y, and I just solve for the X. 84 divided by 6 was the 14. So I would put it on the 14. Then I would cover up the x and have it for y. If I solve for y, I'd get 6. So the y will be 6. Now this isn't equal to, so this will be a solid line. So from 6 to 14. Next, I will graph in green. This next one will be graphed in green. If I cover up the y, x will be 10. If I cover up the x, y will be 10. So both of the greens will be at 10. Both of the greens will be at 10. Those are the intercepts. So then I can connect them. 10. Oops. Try that again. 10 and 10. And the last one, let's graph that in blue, is just the y is less than or equal to 5. So since there's only one variable, I'll go to the y value of 5. And this is going to be a vertical or horizontal. Since it is just one variable, it'll be horizontal, so straight across. I'm doing this in blue. So now we have to shade. So if we shade this in, so the pink wants to be greater than the $84. So that's going to be everything above the pink. For the green, we need to have it less than 10. So that's going to be everything below the green. Then for the blue, it needs to be everything less than the blue. So smaller than the blue. So where are all of them meeting? So I need to find green, blue, and pink. So above the pink, below the blue, and below the green. Right in this little triangle section here. This little triangle section is our solution set. These are the hours that Kelly can work and still make the money that she needs. This little triangle section. So find the solution set to the system and state one set of hours that Kelly can work with her dad and Jana's mowing service to earn the amount she needs. So any coordinate within this location works. So I will go somewhere like right here. Or even right here. It's a little hard to see where the lines are. But if we say maybe 5, 4 looks like about that location. So if we say 5, 4, which really means 5 hours with Dad and 4 hours with Jana's mowing service. So let's check that. So 4 hours, less than or equal to 5, so that's good. So we're just plugging them into here. So the 4 is less than or equal to 5. 5 plus 4 is less than or equal to 10. That's true. That's 9 is less than or equal to 10. Then we have 6 times 5 is 30 plus 14 times 4 is, so that will be 56 is greater than or equal to 84. So we have 86 is greater than or equal to 84. That does work. So therefore 5, 4 does in fact work. This is when we have 3 inequalities and we are trying to find the solution of all 3 of them. It's a little bit more complicated because we have multiple things going on, but you're still finding the location of where all 3 of them meet. Our last problem here says you are selling pizzas to raise money for a school field trip. Cheese pizza costs $8 and pepperoni pizza costs $9. You need to sell at least 2 of each kind of pizza, and you want to sell at least $180 worth of pizza. So we have defined the variables. We have 2 different types of pizzas. We have cheese and pepperoni. So let's go with X is cheese. X is cheese pizza, and Y is pepperoni pizza. So when we write this out, we can put cheese pizza and pepperoni pizza. Okay, so our inequalities. Write a system of inequalities. The first one we have is cheese pizza costs $8. Pepperoni is $9. So cheese is 8, so $8 per X plus $9 per Y. And we need to sell at least $180 worth. So we can have more than or equal to $180 worth. Then it says you need to sell at least 2 of each kind. So that means that our X, our cheese, has to be more than or equal to 2, but also our Y has to be more than or equal to 2. So again, we have 3 different inequalities here. So we have to draw 3 different lines. Let's determine what our largest X and Y have to be. So we already can see that the X and the Y have to at least go to 2. So where should our X go to? So we have 180 and then divide it by 8. So 180 divided by 8. Our X's have to go up to at least 22.5. Then we want to have our Y's. So we're going to do 180 divided by 9. So 180 divided by 9 has to go up to at least 20. So 22.5 and 20. So Y's have to go up to 20. Y's have to go up to 20. We'll do that one in pink. Our Y's have to go up to 20, and our X's have to go up to 22.5. So let's count by 2's. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So then the X's will go a little bit beyond that. And then the Y's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So for our first inequality, that's why we were doing this. So if I wanted to get X by itself, I would divide by 8, and that gave us the 22.5. So about right here. Then we would cover up the X and get the Y by itself, which that is what gave us the 20. So we'd put the other for the Y at 20. Then we would connect them with a line segment. And this is an equal, so it's going to be a solid line. Then we have the next inequality of X is greater than or equal to 2. So I'll do this one in green. This is an X at 2. It's going to be a vertical line. So I will just draw a vertical line starting at 2 and going up. The next one, which I will graph in, let's go with dark blue. We have Y is greater than or equal to 2, so I'll put my Y value at 2, and this will be a horizontal line. So a horizontal line segment, 2. And they are all solid because it's all equal to. So now we can shade. So for the pink, we want it to be greater than 180, so we want it to be greater than the pink line, more than the pink line. For the green, X is greater than or equal to 2, so the green, I need to be more than 2, so I need the green to be towards the right. for the blue, the y is greater than or equal to 2. I need that blue to be above the 2. So above the blue. All of this above the blue. So our solution is where the green, blue, and pink are all meeting, which is all up in here. Along those lines. So our solution is along this green, then that pink, and then the blue, and then everything in this section. So it says you sell 14 cheese pizzas and 10 pepperoni pizzas. Did you reach your sales goal? And explain how you know. So we'll do 14 cheese. Here's 14 cheese and 10 pepperoni. 6, 8, 10. Right here. 14, 10. This is inside the yellow, the highlighted section, so it should work. This answer is a yes because 14, 10 is part of the solution set. We can also check it by plugging it into our inequalities. So if we plug it in to the y, 10 is greater than or equal to 2. That one works. 14 is greater than or equal to 2. So that one works. We need to check the 8x and the 9y. So we'll just use our calculator. So it's 8 times the 14 plus the 9 times the 10. That's equal to $202, which is in fact greater than or equal to 180. So it does work.